as is indicated in the title of this file. Now I'm going to look at type 3. So, step 1 in behavior. So the degree of the numerator and the degree of the denominator. The degree of the numerator we know is 3. The degree of the denominator we know is 2. So now the degree of the numerator is greater than the degree of the denominator. This is type 3. This means we have an oblique asymptote. So we're going to have to do a little long division. We're going to have to divide x squared plus x minus 12 into x cubed plus 2x squared minus 19, x minus 20. Yeah. Okay, well, what do you multiply x squared by to get x cubed? X, everyone says, right? X times x squared is x cubed. X times x is x squared. X times negative 12 is negative 12x. So now remember, in long division you have to subtract, right? X cubed minus x cubed, 0. 2x squared minus x squared is x squared. 19x plus 12x is negative 7x. Bring the negative 20 down. What do we multiply x squared by to get x? What do we multiply x squared by to get x squared? Well, we multiply it by 1, right? So 1 times x squared is x squared plus 1 times x plus 1 times negative 12. When we subtract, we get 0 minus 8x. 20 plus 12 is 8. Sorry, this should be a negative. This doesn't really matter. What we care about is this x plus 1. The difference between the degree of the numerator and the degree of the denominator tells you the degree of the oblique asymptote. So sorry. I'm about to try to erase with my finger and that won't work. So we know that this is degree 1, this is degree 1. So let's put our oblique asymptote on the map. So we have a point here, we're going to go down 1 over 1, go up 1 over 1. I need a couple dots so I can try to draw a straight line on the screen. Alright, so we have an oblique asymptote at y equals x plus 1. Alright, so now everything else stays the same, right? Let's go to a new sheet of paper. That might make our lives a little bit easier. So, step 2, come on, turn colors, there we go. So step 2, that the denominator, come on, equal to 0 and solve. So the denominator is x squared plus x minus 12 equals 0. So we can factor that, right? X. So difference, so multiplies to get 12. We get 4 and 3. We need this one to be positive, and this one to be negative. That means we have a vertical asymptote at x equals 3 and one at x equals negative 4. So let's go back and put those on our graph. At, what did I say, at x equals 1, 2. What was it again? Hold on. X equals 3 and x equals negative 4. So at x equals negative 4, and at x equals 1, 2, 3. We have our vertical asymptotes. All right, next step. Let's go back to our scratch paper here. Step 3. We set the numerator equal to 0 and solve. Well, this one was a cubic function, right? So we got to say x cubed plus 2x squared minus 19x minus 20. So our p is 20. Possible factors are 1, 2, 4, 5, 10, and 20. And since I'm writing the problems, I cheat and make the q easy. Q is plus or minus 1. So these are ones we're going to have to try. Let's do our synthetic division. So we have 1, 2, negative 19, and negative 20. Try 1 first. 1 times 1 is 1. 1 plus 2 is 3. 1 times 3 is 3. 19 minus 3 is negative 16. It's not going to work. All right, try negative 1. 1, 2, negative 19, negative 20. Negative 20, thank you. Bring the 1 down. 1 times negative 1 is negative 1. 2 minus 1 is 1. 1 times negative 1 is negative 1. Oh, look at this. Negative 19 plus negative 1 is negative 20. Negative 1 times negative 20 is positive 20. And we are happy. We can rewrite our function as x plus 1 from here times x squared plus x minus 20. Since we've got a quadratic, we can factor this nice little quadratic. Because we have a 5 and a 4 to make 20, we need this to be positive, so it's got to be x plus 5 and x minus 4. So x plus 1 times x minus 4 times x plus 5. So our three x-intercepts are at negative 1, 4, and negative 5. So let's put those on our graph. Green, right? So we have one at negative 1, one at 4, and one at 1, 2, 3, negative 5. So those are our three x-intercepts. 0, sorry, other way around. Negative 5, 0, negative 1, 0, and 4, 0. Okay, so we can probably do our quick y-intercept here, right? Remember, step 4 is set x equal to 0 and solve for y. Up at the top, it doesn't seem to be working so well, huh? Well, we end up with y equals negative 20 over negative 12, which is negative 10 over negative 6, which is 5 over 3. So go back to our green here. 1 and 1/3. So when x is 0, our function is 5/3. Okay. Last thing, step 5. We're on the last step. Woohoo! Step 5 is not synthetic division, spine chart. Wow. Your professor gets tired too. But let's see. We've got 1, 2, 3, 4, 2, 3, 4, 5 points of interest at negative 5, negative 4, negative 1, 3, and 4. Our factors are at x plus 5, x plus 4, x plus 1, x minus 3, and x minus 4. So, fill in our chart. X minus 3, and x minus 4. Alright, so we have 5 negative signs is negative. 1, 2, 3, 4 is positive. 1, 2, 3, negative. 2 is positive. 1 is negative, and then none is positive. Whew. So when x is less than negative 5, our function, which we should draw in red for good measure, is negative. So it's down here. When we are between negative 5 and negative 4, our function is, oh, wait, I messed up, didn't I? Let's erase this little guy here. This isn't right. Okay, so between negative 5 and infinity, our function is negative. So this way, right? Between negative 5 and negative 4, our function is positive this way. Between negative 4 and negative 1, negative 4 and negative 1, our function is negative. Between negative 1 and 3, our function is positive, and we're going to go through our x-intercept point there. Between 3 and 4, our function is negative, and anything greater than 4, our function is positive. So this is an example of a type 3 rational function with a oblique asymptote at y equals x plus 1. Hope this works. Hope